Hello everyone and welcome to this session. Today I am going to present how to quickly and easily deploy Bolt BI on Azure AKS using Terraform. First, let me introduce myself. My name is Sivakumar and I work at Simplifies Softwares as a DevOps product manager. I have more than 4 years of experience in DevOps. Now let's begin with the agenda of the session. Here is today's agenda. First, I will give a short introduction to Terraform. Next, we will see the advantage of Terraform compared to traditional deployment methods. Then I will explain the prerequisites and how to download the deployment script. After that, we will go into the live demo where I will show you how to deploy Bolt BI on Azure AKS with Terraform. Finally, we will have a conclusion of the session. Before we start the introduction, we will have a quick question poll to make the session more interactive and understand your experience in Terraform. Here is the question. In your opinion, which aspect of Terraform is most important in today's industry? Option A, automating cloud deployments. Option B, ensuring infrastructure consistency across environments. Option C, reducing manual errors and improving reliability. Option D, scaling resources quickly and efficiently. Please take a moment to select your answer.
Hey everyone, so we asked a couple polls during this webinar, but just because you're not live does not mean that you cannot participate. Simply leave your answer as a comment in this video's description, and I'll see you in the next one.
Thank you for choosing your answer. I see that most of you answered automate cloud deployments. That's great. This is exactly one of the key strengths of Terraform, helping teams for deploying applications faster and more reliably. Now let's move on to the introduction to Terraform. Terraform is an open source infrastructure as code tool developed by Tessica. It works across multiple cloud providers such as Azure, AWS, and GCP. It allows us to define and manage infrastructure using code. It automates the deployment process, making infrastructure management more consistent and reliable. Terraform uses a declarative language, which means we only need to describe the final state we want, and Terraform will take care of how to get there. Another important feature is that Terraform always shows an execution plan before making changes, so we know exactly what will be created, updated, or deleted. Now let's look at the advantage of Terraform over traditional deployment methods. The following are the advantages of Terraform. Terraform enables automated and repeatable infrastructure deployments. It supports multiple cloud providers for flexible and scalable solutions. While using Terraform, infrastructure is version controlled and improving collaborations and traceability. And while using Terraform, resources can be scaled easily with the built-in cost optimization features. Now let's compare traditional deployment methods with Terraform-based deployments. In traditional deployments, most steps are manual. This makes them slower and prone to human errors. But with Terraform, everything is automated and repeatable. In traditional methods, each environment, such as development, staging, production, those are configured separately. This often causes mismatches, but with Terraform, we can use the same code for all environments, which keeps everything consistent. Tracking changes in traditional methods is difficult because they are usually written in documents or KB articles. With Terraform, all infrastructure is version controlled in Git, so we can track history or roll back if needed. Scaling resources manually takes time and effort in traditional methods. With Terraform, we can scale up or down quickly by just updating the code. And finally, in traditional deployments, the team depends on documents or step-by-step guides. With Terraform, the team collaborates directly on the same code base, which make teamwork much easier. Overall, Terraform provides a faster, more reliable, and collaborative way to manage infrastructure compared to traditional methods. Before we go into the prerequisites, let's do a quick poll. Here is the question. Which prerequisites do you think is most important before deploying Bolt BI on Azure AKS with Terraform? Option A, having the right Azure subscription and Azure access. Option B, installing required tools such as Terraform, Azure CLI, and kubectl. Option C, setting up app registration or service principal. Option D, access to deployment script and documentation. Please take a moment to select your answer.
Hey everyone, back again. And as last time, just leave your answer as a comment in this video, and you can just add the A, B, C, D, and then the answer just so we can make sure we can separate it from the last poll. All right, thanks.
Thank you for your answer. The above mentioned all are the required prerequisites. I see that most of you answered setting up app registration or service principal. That's great. Authentication is one of the key requirements because without proper access, Terraform cannot create resources. Now let's move on to the prerequisites in details. Before deploying Bolt BA and AKS using Terraform, a few things are required. First, you need an Azure subscription with owner level access, which is needed to create an app registration. You can also need to create an app registration in Azure and provide its details to the Terraform script. You can either assign least required privileges for better security or give contributor access for simplicity. Next, make sure the following tools are installed on your system. The first one is Terraform to execute the deployment script, and the second one is Azure CLI to communicate with your Azure subscription. The third one is kubectl to connect and manage your AKS cluster after deployment. You also need access to the Bolt-based Terraform deployment script, which we have maintained in GitHub. Finally, having some basic knowledge of Azure AKS will help you understand the process of deployment. If you have all those in place, you are ready to move forward with the deployment. Now let's move on to the deployment setups. The deployment process begins with downloading the script. You can clone the repository from GitHub. Next, configure the deployment specific variables such as node size, disk size, and other resource settings. Then run Terraform init to initialize Terraform, which will set up all the required providers and modules. After that, run Terraform plan. This command will show you what resources Terraform will create, update, or delete. So you can review everything before applying. Finally, run Terraform apply to deploy Bolt BA on Azure AKS. Terraform will create all the resources automatically based on the configuration provided. Once the setup is complete, Bolt BA will be deployed on ready to use on your AKS cluster. Let me show you the live demo for this deployment. The documentation you see on my screen is the deployment guide, which you can also find in the session description. As mentioned in the documentation, we first need to ensure that all prerequisites are met. I have already installed Terraform, Azure CLI, and kubectl. You can see the versions installed on my screen. To allow Terraform to create resources, you can either assign least secured privileges using the policy JSON file attached in the documentation, or simply give contributor access to the app registration for simplicity. In my case, I have created a custom role using the policy JSON file and assigned it to the service principal of the app registration. You can see it here. Once prerequisites are ready, we follow the steps. Clone the repository using the command mentioned in the documentation. Once you have cloned, move to the folder where the Terraform script is located. After that, we need to set up the following environment variable to authenticate Terraform with your Azure account. Add the following environment variable to your local system. Here you can find I have added the following environment variable in my local system. Those are client ID, client secret, subscription ID, and tenant ID. Apart from that, we need to add the following environment variables. You can find it in the table below. In the table below, you can find lot of variables, but only required variables is enough for the deployment. Those are database username and database password for the database server for storing Bolt.BA application metadata information. Bolt.BA username and Bolt.BA password that you using for site login, and Bolt.BA license key that you have purchased from the Bolt.BA. For any additional variable, you can refer to the documentation and note that you could store those directly in the Terraform TF files. But this is not recommended for security reasons. You can also use Azure Key Wallet for more secure storage. Now let's look at the Terraform script. Before we move into the demo, let's take a quick overview of what the Terraform script does. The script creates the following resources. First, a resource group, which will be used to manage all the resources together. Next, it sets up a virtual network and subnet for proper network configuration. Then it deploys an Azure Kubernetes cluster, which is the core infrastructure for hosting Bolt.BA. The script also creates a PostgreSQL server, which stores Bolt.BA application metadata information. It sets up a storage account with NFS, which is used to store Bolt.BA application resource data such as app data. Finally, after creating all those resources, the script deploys Bolt BA using Helm on the AKS cluster with the Nginx load balancer and set manager for SSL configurations. Once this setup is complete, Bolt BA is ready to use. In this location, you can find the main script file and the variable file. The main script file defines all the resources that will be created. You can customize if it is needed. In variable file contains resource configuration such as app name, environment name, location, node size, database settings, and other Bolt BA deployment details, including version of Bolt BA. Once everything is ready, open the PowerShell from the script location and run Terraform unit to initialize the script. Once the script got initialized, run Terraform validate to check if the script is correct. Once it got validated, run Terraform plan to check what are the resources should be created. While it's prompted, click enter to continue. In that output, you can see the count of how many resources will be created or how many of change and how many of destroy. For more details, you can refer to the complete output. After that, you can run Terraform apply the script. The Terraform will prompt you for the application hosting domain. You can leave it as empty and press enter. It will automatically create a hosting DNS for the application. When prompted to proceed, type yes and press enter. Now the deployment will start. While the script is running, please wait until it completed. It will take around 7 to 10 minutes. After the script execution has completed, you can see the following output in your screen. Here, let me quickly explain an important concept, that is a Terraform state file. The state file keeps the current status of all the resources that Terraform manages. It helps Terraform understand what already exists, what need to be updated, and what should be deleted. Without the state file, Terraform can't know the actual infrastructure state. Also, you can use the same file for the setup different environments like dev staging or production by updating the variable in the Terraform variable file. While it comes to the scaling, Bolt BI comes with default horizontal pod auto scaling to scale pods automatically. If you want to adjust the node scaling, here you can update the related variable in the Terraform TFR files. Once all done, you can find the DNS URL in the Terraform execution logs. Here is the domain name. Checks the status of the application by enter slash status after the domain name. The all services are up and running. Now open the URL in your browser. Wait until the startup configuration is completed. The screen will take you to the registration page. Please wait. Once the site registration is completed, you can explore Bolt BI and render dashboard. Now that we have completed the demo, let's do one last poll. Here is the question. Which Terraform features do you find the most useful after seeing the demo? Option A, Terraform plan to preview changes before applying. Option B, Terraform state file keeps track of infrastructure. Option C, infrastructure as code, same code for all environments. Option D, easy scaling and update by changing code. Please take a moment to select your answer.
Back one last time for the last poll. And just like the previous polls, you can just leave your answer in this video's comment section and then just add A, B, C, D, and then the answer next to it so we can make sure we know what poll you're answering. Thank you all again.
Thank you for your answer. I see most of you selected Terraform plan and the state file. That's great because those two are at the heart of why Terraform is so reliable. Without the state file, Terraform wouldn't know what already exists in your cloud environment, so it might try to recreate resources or miss important changes. And Terraform plan is one of the best features of Terraform. It shows us exactly what will change before we apply it, which reduces risk and helps us feel confident in the deployment. To conclude this session, let's go over the key takeaways. Terraform makes deployments faster, automated, and reliable. We saw how BoldBI can be deployed on Azure AKS with minimal effort using Terraform. By managing infrastructure as code, we reduce manual errors and optimizing cost. Overall, this approach provides a smarter, scalable, and efficient way to run enterprises BA solution in the cloud. I encourage you to try this approach in your own environment and see how much time and effort it saves. Thank you for joining this session. I hope it gave you clear picture of how Terraform simplifies deployments and how easily BoldBay can be deployed on Azure AKS. If you have any question, just drop them into the comment line. I will be happy to answer this. Thanks again and happy automating.